Here comes today's conceptual problem for thermodynamics. Room temperature is 22 degrees Celsius. What will happen to that temperature when we seal the vacuum desiccator and remove all the air? Do we expect the temperature to go down or up? Or do we expect the temperature to remain the same? Likewise, what do we expect the temperature to do when we allow atmospheric pressure air to rush back in until it equilibrates? Hit pause now and record your predictions and the reasons for them. Okay, let's connect the vacuum supply to the desiccator and see what happens. Whoops, after we reattach it, of course. Now that that is connected, we see it is still at room temperature, and now we will open the valve to the vacuum pump. Keep an eye on the temperature. See the resulting impact on temperature. And you see that removing air from the chamber causes a decrease in temperature. Now this is followed by a return to room temperature, and that is because what changed temperature is the air that remains in the chamber, not the plastic walls of the chamber itself. So it will return to room temperature as we sit here and watch. Actually, I'm going to speed it up a little. Now, the chamber is still under vacuum, but has returned pretty much to room temperature. I'm going to turn the vacuum off and then release the valve at the side of the chamber itself, and you'll see it return to atmospheric pressure. Watch what happens to the temperature when I do so. And here we go. You can see that we get an immediate and substantial temperature spike as atmospheric air is returned to the chamber. And remember, that air was at room temperature. Once again, that temperature spike is transient because there isn't a whole lot of air in the chamber compared to the thermal mass of the plastic itself, which will bring this back to room temperature pretty quickly. But that's our experiment, so take a moment and think this through. Why did the temperature go down, and why did the temperature go up? And here is a hint: it is not just or even mostly about the ideal gas law. I think you should think about work and internal energy and enthalpy. Talk to you soon.